The structural formulas of carbon and other atoms will show you the exact way of connecting them to each other using a short straight line known as a bond. We will discuss how the structure of the carbon atom affects the types of bonds it forms: single bond, double bond, and triple bond. Carbon is the same element present in all living things and some non-living things such as paper, coal, and diamond. Carbon forms organic compounds with many other atoms like hydrogen, oxygen, nitrogen, and halogens, which can form complex structures. The compounds which contain carbon combined with hydrogen, oxygen, and nitrogen, and few other elements are usually called organic compounds. Organic compounds have low thermal stability, usually decompose, easily char, and burn when heated. Thus, organic compounds have lower melting points and boiling points due to its weaker bonds, which are covalent bonds. Salt is classified as an inorganic compound that has a higher melting point compared to sugar. Sugar easily melts in the presence of flame or fire and eventually changes its color to black. This is an evidence that an organic compound has a weaker bond and its chemical properties change, like its color, odor, and taste. The only distinguishable characteristic of organic compounds is that they all contain the element carbon. Carbon is the most common element present in all biodegradable materials. It has a unique ability to bond elements together and form long chains and rings. The ground state electron configuration of an atom is a description of the orbitals that the atom's electrons occupy. The carbon atom with electron configuration of 1s2, 2s2, 2p2 has 4 electrons in its valence shell or outer shell, while hydrogen with electron configuration of 1s1 has 1 valence electron. Gilbert Lewis, an American physical chemist, discovered the covalent bond and his concept of electron pairs. The Lewis dot structures and other contributions to the valence bond theory have shaped modern theories of chemical bonding. Carbon bonds to other atoms, not by losing nor gaining, but by sharing its electrons. The 4 valence electrons of carbon represent the 4 dots of carbon in its Lewis dot structure. For a hydrogen atom, its valence electron is represented by 1 dot. According to the octet rule, a stable molecule results when the valence shell of 8 electrons has been achieved for all atoms in a molecule. For carbon to be stable, having 4 valence electrons, it needs 4 more. 4 atoms of hydrogen can form 4 covalent bonds with carbon. Bonds are usually represented by a short straight line connecting the atoms, with each bond representing a shared pair of electrons. Electron sharing occurs when 2 atoms approach and their atomic orbitals overlap. Bonds that have circular cross-sections and are formed by head-on overlap of atomic orbitals are called sigma bonds. Bonds formed by sideways overlap of p orbitals are called pi bonds. The simplest and most commonly encountered class of organic compounds are the hydrocarbons. The structures of hydrocarbons affect their properties, such as their physical state and boiling point. There are 2 types of hydrocarbons: saturated and unsaturated. Saturated hydrocarbons are called alkanes. Unsaturated hydrocarbons are further classified into alkenes and alkynes.
The term allotrope refers to different forms of the same element. Right in our giant covalent structures lesson, you may have learned about the structure of diamond and graphite. These two substances are made of only carbon atoms, yet they exhibit very different physical and chemical properties. A diamond is very shiny, remarkably strong, and does not conduct electricity. Graphite is black, not nearly as strong as diamond, and can conduct electricity. These differences are due to the arrangement of carbon atoms within the structure. Each carbon atom in diamond is covalently bound to 4 other carbon atoms in a tetrahedral structure. Each carbon in graphite is covalently bound to 3 other carbon atoms in a trigonoplanar structure forming hexagonal sheets. Some other allotropes of carbon include the Buckminster fullerene molecule and graphene. You can learn more about these structures right here.